Hi there, data scamps and data champs. This is Richie. So, AI assisted coding is the future, and frankly, the future is already here. So, being able to write code with the help of AI is how things are going to be done going forward. And for those of you who are regulars in these webinars, you'll know that we've previously run some sessions on AI-assisted data analysis, both in ChatGPT and in Data Lab. That's the platform formerly known as DataCamp Workspace. And today we're going to give AI another challenge by making it help us with a machine learning project. So just note, if you want to follow along, you can need to use a ChatGPT Plus or Enterprise account, since the code interpreter isn't available in the free version. Now, our guest is Francesca Donadoni, an AI curriculum manager here at DataCamp. That is, she's helping create the AI courses and projects on our platform. Francesca was previously a computer vision researcher at Catalai, a machine learning engineer at Arthronica, and a clinical data research scientist at Northwell Health. So plenty of experience in the AI field and data field as well. And with that, over to you, Francesca.
Thank you, Richie. Very excited for this code along and to dive into the ChatGPT code. Riz has shared a notebook where you'll be finding the dataset. The dataset is mainly about some carbon emissions and how they get generated based on individuals' habits. And so you will find things like, for example, the diet, transport modes, recycling habits. I can actually show you, I've got it open right here in a Google Sheet. And you can see some data is of the categorical type, some is numerical. So we're going to take a look at using ChatGPT to provide us with help on data visualization, but also on doing some machine learning modeling and specifically using regression. So let's dive in following the prompts. First, with the paid version, so as Richie mentioned, we're going to be using the paid version. We are able actually to upload data sets and we can ask questions directly. You might have seen it in other previous code alongs about the data and about the data sets. So let's start with the first one. We're going to ask to load and inspect the data set and to visualize the data in a way that we are able to recognize some main trends. Let's see what it comes back with. I'm expecting it will probably recognize the columns, and I'm hoping that it will recognize that there are categorical and numerical variables. You are also going to be able to see the code that it will when it does generate code. So at this point, actually, he's just giving us an overview of the columns. And let's check maybe a couple of those to see if, got them right. It's saying, yeah, body type, sex, diet are all categorical variables. And if we go back to our spreadsheet, looks like it's getting the columns right. Let's see, I'm looking for some numerical variables. Yeah, so things like monthly grocery bill, vehicle, monthly distance, waste bag, weekly count. It all sounds like they are numerical variable, and it looks like ChatGPT got it right. Yeah, vehicle monthly, waste bag was waste bag weekly count. Yes. So here are our first few plots. So it went for some bar charts. We can see the distribution, it's very equal, so there's not much unbalance. The variables are quite well balanced, and you can even see how it generated this code. So it doesn't show you in the response because it's already quite long, but it puts it in this button here, and so you can click and if you want to take a look at the code in your own time and even make changes, you can do that. So we've got categorical variables. We've got an explanation of what the variables are by ChatGPT. And it looks like, again, it understood what the dataset contains with the body types, with the male and female, various diets, and other variables again. Now let's look at the numerical variables. So numerical variables provided some correlations already. So it looks like it almost understood already what we are trying to do for the numerical variables, and it's also provided the code through which some plots can be made. It didn't, so unfortunately, it didn't make it to actually visualize the data. It's probably because there's too much numerical data in the set. So this code compiler that's on the chat, it only goes so far, but for more complex analysis, you will have to switch to a code platform like the one available on DataCamp or your own personal. So pretty much, I think I'm pretty happy with what is done so far. It recognized the variables. It was able to see that there are some categorical and some numerical variables. But let's say maybe we are doing this for work, and we want to also present the interpretation of this data to a non-technical colleague. So let's see how ChatGPT does in explaining the plots and the interpretation to a non-technical colleague. Here we go. And I'm hoping that it will not, that we will at least explain things like a correlation in some more clear way, and maybe give some interpretation of the plots that is made. Maybe saying something about how the variables are well balanced, or maybe giving it more. So actually, it's going it's going some deeper into the data, and it's picked up some correlations. So it's picked up these correlations that I was presenting, for example, with the vehicle monthly distance, and explain them in a clear way, in a non-technical way. So it makes sense. So it's picking up some trends. It's not clear which one of these variables is the strongest one yet, but I think we can see that if we start cleaning the data and build a real machine learning model. So let's get started with this. We're gonna now ask to start cleaning the data and identify missing data to either remove them or replace them. We're gonna give the choice, leave the choice. Here we go. My approach would actually be to remove, so there is a column that's called vehicle type that has a high percentage of missing values. I think it's about 60%. So my approach would be to remove the column, but let's see, maybe we'll substitute the values. I'm hoping that it doesn't remove the rows, because otherwise it would be 60% rows removed, which will leave us with not much data. So hoping that it gets it right. Okay, so it's replacing the missing value. I think that's also fine. It's replacing the missing values. It's not saying with but I think we can check the code with the most frequent vehicle type. So I think that's not a good approach, because we don't know if the missing vehicle type is actually the most common vehicle type. It could be that if this was a survey, for example, it could be that people were actually not taking any vehicle. So I think I'm gonna deviate a little bit from the prompt and ask to actually replace it with something like unknown. And so that we have a better result. And this is just showing how the output varies. So when I did this previously, it was sometimes taking the column out, sometimes replacing the value with something like unknown, and so yeah, it just shows that these models are quite they vary quite a lot in their output, and it's always good to keep an eye out for these kind of things. So it looks like the dataset is ready for the next steps. We've updated the label with unknown, and I think we can ask as the last step to get the data ready for a machine learning model. Normally we would encode the categorical variables and do some scaling of the numerical variables. So I'm going to ask to do the same in the chat. And let's see, also here I'm curious to see if it's going to decide to one-hot encode the categorical variable or label encode. And I know that one-hot encoding would be preferable, because most of these columns don't really have an order. So for things like body type, female, male, even diet, we don't really know which one contributes, if they do, if they even contribute more to carbon emissions. So it might be that they don't. And in that case, the one-hot encoding is preferable. But at the same time, as I said in the beginning, this this code compiler only goes so far. So if we one-hot encode the variables, we risk generating too many columns for the platform to handle. And so I'm just gonna be conscious of that. Yeah, it's chosen to one-hot encode the categorical variables, and so it's created. It's created 66 features, which is going to be a bit too much for the platform to handle. So again, I'm just going to say to use the label encoding instead. Yeah, and after this, we should be ready for the model development part. So we're gonna, after this, move to picking some regression models. We're gonna have linear regression, lasso regression, and finally a random forest. And then we're gonna see which one is the best performing one, and have the model choose, make a choice, and also calculate some scores. So this is the pretty much wrapping up the first part. And let's see if, so it did a label encoding, and we should have different codes for different categories. Is explaining it here. So I think the nice thing is that we can always ask to explain what it's doing with the code, and also visualize the code. And so here it's saying that these columns have been encoded into integers, and as opposed to one hot encoding where it was building a new column for each of the subcategories. So we're ready to move to the model development part, and I'm going to paste my first prompt asking to start with the linear regression. Let's see how it does for the linear regression. So it's saying it's preparing the data into a training and testing set. And I think this is really good that it's recognized that this is needed, because I didn't prompt it with any instruction to do this, and it's just something that it knows how to do. And then train the linear regression model, and it's actually picked up some scores, which these 3 scores: mean, absolute error, RMSE, and R-square, which all make sense. I think they're all good for measuring performance on a regression. So I'm happy to go ahead and see how it's getting. So, okay, the result is 0.59 R squared, which means the model only goes as far as 59% explanation of the variance in carbon emissions. So basically using these variables that we have, we can only explain 59% of the variance using this model, which I think is a good baseline. Yeah, and hoping that we get a better performance with the other models. Let's see. So it's given an explanation of the metrics as well, and it's also saying that we have room for improvement. So I agree. And now moving on to the lasso regression. So the lasso regression is similar, but we're going to have a parameter that it can adjust. And in this case, it will only have one run with one parameter. So with lasso regression, we could do a parameter sweep to see if there are coefficients that work better. But this is, again, a limitation of doing code only using the ChatGPT chat. And so we won't be able to do it right now, but we can ask for example, ideas on how to improve the model and other parameters that we could potentially change. Okay, so we are again at 59. So it's not performing great. I think we can try with the random forest to see if it improves, because I think, if I remember correctly, it's pretty much the same as the linear regression. So let's just check. Yeah, exactly the same. So I think we're going to check how the random forest does. And this is the last model for now. Again, we could go into more complicated models, but that would need probably a separate platform to test the code on. And it's given us, looks like, an explanation of the random forest as well, which is quite good to read before the model is trained. So it's less prone to overfitting compared to decision trees. It can handle outliers more effectively. It provides insights into which features are the most important. So it looks like it's a more promising one than the previous 2 regression models, but I'm curious to see the results. So for the first couple of metrics, it's gotten better, and it's gotten better for the R squared as well. So now we have that using the random forest, we are able to actually explain up to 90% of the variance, which is a great improvement with respect to the previous couple of models. So we got a decent result. And now, instead of going up and check the other couple of models, I want to ask if it remembers the previous course. And I want to ask to compare the models and provide the best performing ones and also make an explanation for the choice. Let's see if it remembers. Yeah, it looks like it remembers the models. It remembers the metrics that we used. And we have the comparisons here. Yeah, I would have maybe liked if it had done some table, but these are all things that we can always ask, or some visualizations maybe with bar charts. Let's see what the response is on the choice of best model. So it's definitely the random forest, and it's saying that it reduces prediction error and provides a more comprehensive understanding of how the features affect. The explanation is that there's probably non-linear relationships in the dataset that are better handled by the random forest rather than the linear models, which is yeah, totally making sense to me. And since it's talking about features that potentially affect more or less carbon emissions, I'm curious to ask what are these features that contribute the most? Because maybe imagine you're doing this for a work project. You could tell your colleagues not only what the model does and how accurate is the model, but also what are the features that contribute the most, and give more of an explanation of what the study that you did concluded. So it's something that can be quite easily done using the random forest. It's a little bit more tricky with other models, but it should be able to handle it. Let's see. And it's probably going to use a library in Python that does exactly that. So let's see what the code looks like. First it's giving us a nice plot, which could be maybe something you can use to present again to your colleagues. It's got a good visualization. It looks like the vehicle monthly distance is the most contributing factor to carbon emissions. And then second, frequency of traveling by air and vehicle type. So a lot around the transportation. I was looking for, it didn't give the code. Oh no, it's probably at the bottom. Yeah, so it's at the bottom. So you can see it used the feature importances from the random forest model, and then sorted these features by the importance coefficient and use the bar plot. So pretty good code that you can use yourself and you can recreate. And it's also given a small explanation on why this could be reflected in energy consumption. And so after this, again, if we were in a work project, now we have our model, we have our visualization. We might want to explain the results to the model to our colleagues, maybe to some technical colleagues and to some non-technical colleagues. And I want to ask to give this explanation for these two different audiences. So let's see how it does on that. I'm expecting for the technical explanation, to be more around the coefficients and what the coefficients mean Whereas for the non-technical one, maybe using a metaphor or like more a bit of storytelling or more general overview of what the model did. So gave an explanation for the technical audience on what the random forest is. So it's an ensemble of decision trees and about the performance metrics and how also the feature importance identified certain predictors. And then it doesn't talk about the other models, which I'm a bit disappointed about because I would have included them. But again, it's something that you can always ask to add, or you can go back to your previous answers and integrate the answer from ChatGPT. The non-technical audience one, it doesn't mention the name of the algorithm, which I appreciate. Not everyone would know random forest as a technical audience, and it's just saying that the tool is quite accurate at 91% explanation of the reasons for the carbon emissions. And so generally saying it can help identify activities that contribute the most to carbon emissions. So overall, it gives an example of, for example, using transport more increases carbon emissions, but the difference are quite clear. I would have liked if it had included the other models, but I think, we can be quite happy with it. And I have a couple more questions that I wanted to add to this. I didn't put them in the data lab that I shared, but I wanted to check in if there were any questions first.
Yes. So we do have a couple of questions worth going over. So the first one is from Evan. So Evan asks, how reliable is the output being demonstrated in terms of hallucinations?
Yeah, so from my experience, it needs to be guided a little bit in the sense that you always need to check what that it makes sense. You can do some checks comparing your output and, for example, Excel, a bit like I did for when it was choosing between categorical and numerical variables, checking that it was picking the right variables. I found it in general, let's say, 90% of the times it was accurate, but it always needed a bit of that check. So I would say 90% of the times you can trust it, but I wouldn't trust it blindly because that 10% can really catch you up.
Yeah, I mean, I suppose one thing that's worth noting here is that hallucinations are normally it's just stated something that is completely fabricated from scratch, but in this case, it's Python that's actually it's executing real Python code to do the data analysis. So we know the Python at least should be able to calculate stuff as long as the code is correct. So you probably want to double check the code, but if the code's right, then the output ought to be right. It's not going to be just made up from nothing.
Exactly, yeah. And I think that's really what helps you save time on things like this, because as long as you check that your input data is right, that it didn't add any variables or didn't misinterpret any variables, then the rest of and the code is looks right, then the rest is trustworthy. So
absolutely. Actually, I have a question for you related to this. So prompt engineering question. So when you're asking it to perform different tasks, I've noticed that in general, some of your prompts were sort of fairly general, just high level tasks. And then if it's done something that you didn't want, you went back and said, okay, don't do that, do this instead. Do you think it's better in general to have broader, high level prompts or be more detailed about exactly what you want?
So I think if you can, it's better to be more detailed so that you are guiding the model. But I wanted to also give an overview on what would be the case when you maybe don't have that level of detail, and also show what happens and how the model can have different outputs, because actually in different times that I did the same exercise, it gave me different outputs. So I think the more level of detail, the better to minimize this risk of going out of what you wanted to do. But at the same time, you can still take a stab at it if you're a beginner.
That's interesting. So basically, I suppose the trade-off here, partly if you're writing more detail, it's going to take more time. And so, well, no one likes typing. And then also, if you don't know exactly what you want, then sometimes you can just be a bit more general and hope that ChatGPT gives you the right answer. So it might get you somewhere, even if you're not sure what you want. All right.
And for example, in the case before, maybe if with the vehicle type, when it's substituted with the most frequent vehicle type, you would have probably realized that it had done something wrong, because maybe the models that you were getting were not, you were not getting a high score. So I think you would realize, just keep checking your metrics, which is something that beginners can do, and you can tell when there is something that is not looking quite right, looking at the metrics normally in general. So.
Absolutely. Okay, yeah. So check your answers and see if they sound sensible. That's a good way of checking things. All right. So this next thing is not so much a question as a comment. But Adrian says, "Yeah, I find this really impressive. I had no idea ChatGPT could do this. I'm going to go out of work soon." So talking about changes to data careers and AI careers, this is something we've covered quite a lot in webinars and also on the podcast. So there's a couple of episodes of Data Frame that I think are worth listening to. So the latest episode with Tom Tungus, he's a venture capitalist. He's talking about how this is going to affect data careers, and then also Bernard Marr we had on a month or two ago. He's also talked about which jobs are sort of safe from being taken over by AI and which ones are going to be enhanced by AI and which ones aren't going to be affected at all. So both those episodes are worth listening to. All right. Next question comes from Monica. So Monica says, can you save the results or save the model for further prediction? So if you want to download the results, how can you do that? I don't know whether that's something you want to go over or later in the session, or whether it's something you need to talk to now.
Actually, so I did try to download, and there is a download button, but you can only share. So you can only share if you want to share this with your colleagues or with your teammates. It doesn't look like there's any way to actually download the full script and the code. But what you can do is you can copy and paste the code and then run it locally. So if you, as you go through, copy and paste the code, and then you have any sort of way to compile it and run it, then that would save your model. But there isn't, as far as I know, a way to do it from the platform.
Okay, yeah. So that sounds like a sensible approach, is just copying the code and putting it into your favorite IDE, or perhaps even Data Lab. I think you can download images as well. So if it creates any plots, I think there's a download option for the PNG files.
I think so. I think for the plots, there should be a way. Well, yeah, you can save it as an image. I don't know if there's a way to directly do a download as there is for the share. But yeah, you can save it as an image, save the code, and As far as I know, that's the most that you can do in terms of saving it to your local environment.
Okay. All right. We'll go through one more question for now, and then we'll take the rest of the questions at the end. Got a lot of great questions from the audience, actually. So we'll make sure to leave plenty of time for those at the end. All right. So this next one's from Penelope. So Penelope asks, what's the difference between the paid and free versions of ChatGPT, particularly with respect to machine learning code? It's good that you got it to work with the free version. Francesca, do you know?
I think with the free version, you probably wouldn't have been able to upload the datasets. There's no like icon for uploading as there is here, where I was able to upload the carbon emission CSV. But it also, so with the free version, you are able to generate code. It just wouldn't run on your own data. You would have to download the code and then make changes and adapt it to your data.
Yeah, it's been a minute since I used the free version, but as far as I can tell, like, yeah, you don't get access to GPT-4. You only get GPT 3.5, which is like the older model.
Yeah.
And I'm not sure whether the actual code interpreter is available in the free version or not. So it can generate code, but you can't necessarily run it, right?
Yeah, I think.
Yeah. Okay, so this, I'm sure OpenAI must have a feature comparison plan for different pricing options. Have a look at the OpenAI website, or even ask ChatGPT itself and see if that'll tell you. All right, I'm gonna head off. I'll let you continue, and we'll do more questions at the end.
Thank you. Yeah, so I think we can do one more question. I wanted to, as I said, I think one good thing about this tool is that you can ask as many questions as you need, and also how to explain different parts of what it generated. And I wanted to ask how it evaluated the model and what were the definition of the metrics, because I feel like we went past those quite quickly, and I want to see what answers will I get. So yeah, again, the metrics were the mean absolute error, the root mean square error, and the R-square score, which are quite common for regression. But yeah, for example, the definition itself, some people might need like a refresher or so. I think, again, it gave us the mathematical definition, and it gave us a text definition and interpretation. So here, with mean absolute error, a lower mean absolute error indicates better accuracy, because the difference between the predicted and the actual variable is lower as the MAE is lower. And then root mean square error is basically the same but squared, which is useful because then you are in the same sort of like the same value range as your answers. And then the R squared is a bit more complicated, but generally it means what is the percentage of answers that you're able to explain with the variables that you have. And again, it's the one that we got to 90% with the random forest. So it's also giving us a explanation of why it picked these metrics, which I think it's interesting because it chose 3 metrics, and I was expecting maybe to come up with just one. In traditional data science, you would normally use one, but it's maybe good to have different ones to get a more complete picture, as it's saying here. And for the R2, is also saying that it explains the proportion, as I said before, of the variance that is dependent on the data that you have. So it gives you more of an overview of how efficient is your model, how effective is your model. Yeah. And I think since there were more questions, maybe do we want to address the questions first and come back to this if we have more time? Or maybe there are questions that the audience would like to ask.
All right, yeah. So for anyone in the audience, if you want to ask ChatGPT some specific questions, we can go through those. In the meantime, there were some more questions that we didn't get to before, so let's go through some of those now. All right. So this next question comes from Emmanuel. So, what sort of size of models can be tackled by ChatGPT in this way? So, yeah. So I guess how big a sort of model can you create, and how big a data set can you use? I'm not sure what the limits are.
Yeah, so again, I'm not sure of the exact limits, but I did try a neural network, a really simple, only a few layers, and it wouldn't run. At the same time, yeah, random forest ran, and I think I also did try XGBoost, and it ran one time, but the other time it didn't. So I think the random forest is the limit to to the models running all the time without problems, and above that it gets more complicated. And the same with if you want to do a parameter search, it's very difficult. So I wasn't able to run a parameter search.
Yeah, I think it sort of times out after about 30 seconds or something. So if you expect your code to take more than 30 seconds to run, expect it to not work in ChatGPT. And then also, I presume the Python interpreter, the machine it's running on, has got to be pretty low powered. These things are expensive. So yeah, if you want to do big data analysis, then this is not the platform for you. All right. So next question comes from DB World saying, thank you. Can you do time series forecasting and unsupervised clustering?
Yeah, again, it's similar to the answer to the previous question. Like normally for these type of prediction models, you need very large data sets. So I'm not sure that it would be able to handle. It definitely has the capabilities, but probably if you have a smaller data set, and at that point, I don't know how accurate it will be. So it's still able to generate code for it. So I would still use it, for maybe some code generation, and then transfer to my own platform to do more testing and saving the models and these actions that require more memory.
I suppose that's one of the good things is that the code you need to write for a small data set or a large data set is maybe not absolutely identical, but it's going to be very close. So you can, get ChatGPT to write it on the small data set, and like you said, go away and put it on a higher powered platform with the full data set afterwards. Nice. Okay. Excellent. Another question from Adrian. So Adrian asks, what sort of data forms accepted? I think we've covered limits on size of uploaded data sets, but so we used CSV files here. Do you know what other formats are supported?
Yeah, so it actually, you can upload any format, but it will ask you to convert to some format that it records. So I don't actually know exactly all the formats, but I did try a different format, and it asked me to transform into a CSV. So CSV is always, very well accepted. I think JSON is as well. For all the other formats, I think just try, and if it doesn't recognize it, it will ask you to transform into some other format that it recognizes.
Okay. I suppose in theory you could get it to write some Python code to convert it or import it using whatever. I mean, like Python, you can import pretty much any sort of data format. You just got to get the right package to do that. Have a play around, see if that works. I have no idea. Okay. Next question comes from Saeed. So Saeed asks, how might you go about drawing box plots for different models?
Yeah, I actually was expecting it to draw box plots for the categorical variables. I think that would be a good question to ask. Should we ask now?
Yeah, let's try it.
Let's try. Let's pick maybe one categorical variable. I would pick a diet just to see if it works. And then it should also show the code if it works. And then at that point, you can recreate it to any other variables as well, or you can ask it to plot it for all the other variables. But I'm also curious to see if it works and what kind of plot it creates. The dataset, again, is quite balanced. So so we have some box plots. It looks like for the omnivore diet, it is a little bit higher on the carbon emissions. Yeah, which makes sense with the beef being like more intensive in terms of emissions. And I'm looking for the code. Yeah. So you also have code here, and you see it uses Seaborn for box plots, which you can replicate with all the other categorical variables. So yeah, it looks like it was able to do it.
Excellent. That's cool. I do like box plots. They're a fun plot type. All right. So next question comes from Joseph. Can we adjust pre-trained models from ChatGPT to be specific to the context of our data? I feel like we sort of did that today, but yeah, do you want to go through what the workflow is there?
Yeah, so the models that are available are pretty much all the models that are available to you through the Python libraries. So any of those that you can think of, unless they go above the limits. And I'm sure that these limits will get better and better, so you'll be able to run more models. But anything that you've been using locally or on your cloud platforms coming from Python library is available. So yeah, definitely we'll be able to use for fine-tuning. Fine-tuning normally implies there is a deep learning model, so that is a little bit more complicated, but that's just because of the size. It's not because it's not available. It's just a question of how much computing power does it need, and is that below the limit. But other than that, yeah, you're good to go.
All right. And last question for the audience for now. If you've got any more questions, we've still got plenty of time, so please do ask away. So this comes from, I'm not going to try to pronounce your name, Con something. Connor, perhaps. So Connor's just asking, is there still a limit to how many questions you can ask GPT-4? There was a limit of like 50 questions per 3 hours or something. I think that's gone away though.
Yeah, I have to check. I've never like run into the limit. Yeah, I would have to check that. I'm not sure. The amount of questions I think was quite, like 50 questions. So I think it would be quite big for something like a machine learning analysis. But again, maybe if you're doing more than one, or if you're asking a lot of follow-up questions, and again, I would have to check that it's still valid, because I'm not sure if they've taken it out.
It used to have a message on the bottom saying there was a limit to the number of messages you could send, but now it's not there. So there may be a limit, but probably higher. If you run into a problem, then yeah, you need to set a second account or get the enterprise plan. All right, we've got two more questions. This one's from Sarah. So Sarah's saying she's not getting the plots, but I'm getting the code. I think if you're using the free plan, then I'm not sure it generates plots.
No, yeah, the free plan doesn't generate plots. In the same way that it doesn't generate images or anything that is visual, unfortunately. But if you're using the paid plan, it should be able to generate plots. If you're not seeing them, maybe try to rephrase the question and see if that helps. Sometimes it's an interpretation issue.
All right, so can we run? Massimo asks, can we run the same prompts in Data Lab as well? Short answer is absolutely yes. So yeah, the AI assistant in Data Lab is powered by GPT, so same technology underneath. What we do in Data Lab is we provide all the context around your data set in the prompt to GPT automatically. So GPT will know like what data connection you have available, what variables are there, what columns are in your data frames, all that kind of stuff. So you get a lot of information is passed to GPT automatically. You don't need to worry about it, and so it does give you pretty good results. Yeah, same kind of stuff. It's just the DataCamp way. All right. So that's it. We're out of questions for now. Before you all dash off, we have got some very exciting webinars coming up soon. So there's a session on learning tomorrow. So we've got a Stanford professor coming in talking about how to learn. Well, she's focused on mathematics education, but works with data as well. So just talking about like how to teach and learn more effectively. Next week, we've got a code along on Tuesday covering cloud computing. So how to do data science in the cloud using the Amazon stack, the AWS stack. And then there's a session next Thursday on understanding regulations for AI. So tons of exciting things coming up. Click on the QR or take a photo of the QR code in the top left for future events, and please do register for those. Thank you very much, Francesca. That was very cool. Like, I love that we actually we generated code. We got AI to interpret the results for us. It sounds like data science is going to be a little bit easier going forward. So that's excellent stuff.
Yeah, we packed quite a lot in an hour.
We did. I was amazed. Like we got through the whole machine learning workflow, and there's plenty of time to spare for questions. So that's a good sign for productivity. Brilliant. Thank you to Reese for moderating. Thank you to everyone who asked a question. We had lots of great questions today. Very impressed audience. And thank you to everyone who showed up as well. I hope to see you all again in future